Okay, this should be the last film to review this project. I know that these walls have changed, but this was what I was putting together earlier with regard to the foundation. The foundation needs to come out in front of this structure in order to provide clearance for the column bases at the bottom of these columns. The three columns at the end supporting the three beams, those require CVSQ 44, and that requires 3 inches of clearance from the edge of the base. And since the bases are 4 inches after the straps in one dimension, that really means that you need a 10-inch wall centered under that 4-inch base, or at least 10 inches of concrete, and that's got to go down at least 3 inches below the base, so 11 inches down. Now the 4 columns back south against the brick, flanking the doors, etc., those will use a lighter base, a PBS 44Z, and that only requires 2 inches from the edge. But it doesn't really matter because I assume we want this symmetrical out there at the corner where it has the same projection in both directions. As I said, I made this model earlier, and this was only projecting, this as shown, it only projects about an inch or so from the face of this because there was 2 inches under it. But in the final permutation, you'll see here in a minute, this the surface of this foundation comes out 2 full inches in front of the surface of this structure to provide that 3-inch clearance for the column base. So at all the margins you have this bevel, and except at the doors there it has to come out. So this all has to be formed as it's poured or right after it's poured. This stuff has to be taken care of. I suppose these corners are clipped off on that sill. But this one here now you can see is the 2-inch projection. You can also see that line of aluminum flashing underneath the cedar and over the concrete. The same sort of thing happens on this side as well. I didn't want to just run that same bevel in front of the doors. It would tend to be a slipping or tripping hazard. It just wouldn't be correct. And I think this is probably the best we're going to do with the interface at the bay window roof and this roof. As I said, I don't care for it, but I don't know a better solution that's not expensive. And so currently, because of the site and the undecided nature of how exactly this foundation is going to be put together, I'm showing 2 different alternatives at the drawing plans. There are these. Foundation 1 is a monolithic pour where we just fill everything in there and come down with 1 foot wide walls. This would have to be formed above the grade. I don't know how that's done. I'm not a concrete person, but that would need to be formed above the grade, and then all this bevel work and edging work done, all while it's poured at once. The other alternative, foundation alternative 2, is a 3-pour arrangement where the I assume it's going to take a 2-foot footing for your person to form this up there. So the footings, and then 8-inch walls, but the front wall is going to have to be a 10-inch wall. At least that north wall has to be a 10-inch wall. These flanking ones can be 8-inch walls. And then finally the 3rd pour is the cap over, and you have to have some sort of separation here, I assume. So this pushes this out. So this projects about 2 inches from the face of the structure, and this one projects about 3 inches because it has to have some sort of separation here. So that said, I wanted to see kind of how much concrete either one of these was going to take. That might help a person make a decision about which way to go. And this is what I did to kind of figure that out. These are probably fairly reliable numbers. That's just that surrounding part there. And then you can see this is at the front end, at the north end. This is how the grade, at least according to what the best I could do, this is where the grade is, where the screen is coming down. So if we were just going to fill that, if a person was just going to fill this all in with concrete, and if they're going to scrape that off level, move all this stuff so everything is just level in there, if they were going to do that, these are kind of these, and so all that is filled with concrete as well, and all of that is poured at once in alternative 1. The infill concrete alone is 13 yards. This part is 11 yards here, and this part is another 14. So the monolithic pour, it looks to me like, particularly if all this earth is scraped off to about this level, we get down to 2 foot 8 below grade, wherever it is, the monolithic pour all at once would take 25 cubic yards, which seems like an awful lot of concrete. But that was my calculations on the monolithic pour. On this here, and I'm showing 8 or 9 inch walls, 10 inch, it's 10 inch at the north end and 8 inch down the side is what it would be if you use this alternative. With the footings 2.5, the walls another 5, and the cap another 5. And so about half the concrete for this here, but you have to pump it 3 times instead of the once. And then you'll need this kind of infill gravel, I assume about the same amount in yardage for infill gravel. So I just wanted to run that just so that you would have that information. I don't know that that helps. I think it comes down to what is going to be logistically sensible. And so this is sort of this final structure, or the condition it is right now. It's 17 feet deep, and I've put these walls in, about 2 foot walls. Actually, I think they're 2 foot back here, and then they end up at about 2 foot 6 or 2 foot 2 out here because of the sloping of that slab. I suppose you wouldn't even have to slope that slab. You probably could make that level, but I'm not sure about that. I'm showing it sloped 1/8 inch per foot from the door out. I'm showing this sloped 3/16 per foot this way, down slope. And I don't know how large your table is. Damon was telling me about a table you want to put out here. If you want to send me a photo on the side of that table, I can show you how it fits on this, or if we're going to expand that, I can model that for you, and you can make a decision on what the shape of this is, or how big it is, or if this is enough. One other adjustment I made when I put this heavier beam back in here, this heavier member back in here. For one thing, I think that can just be a box beam made of plywood and 2x4s. But if originally I was showing 2x2 bars that easy screen cells between these units, between this one, between these, and up between the traps. Those were 2 inch by 2 inch bars. If you wanted to just use solid cedar, it has to be at least net 2 inches wide. But I called down there, and you could get a piece of 4x6, split that in half, and then use like 2 inch wide by 2 5/8 deep solid wood members between those. So you could barely see some of that light colored wood inside instead of the metal that I had been showing. That's completely up to you how you treat that, but it can be just wood. And so I just wanted to cover that. And these are just the outside photographs of that finished 17-foot deep structure. And I think that does it. I just have to add labels to the section, and these are ready to apply for a permit. So let me know if there are any further changes. Thanks.